Okay, here we go. Word problems involving differential equations. So, translating from English into math. Pause and copy. Pause and copy. Okay, slope of the tangent line. How can I translate that into math? Well, that is dy over dx, right? And we're told that that is equal to negative x over 2y. So dy over dx is equal to negative x over 2y. And we have this extra information. When x is 1, y is 2. So let's write that down. When x equals 1, y is equal to 2. So this is our initial value problem, which we can solve by separation. Solve that by separation. So I separate. What do I get? I get 2y dy is equal to negative x dx. And then you integrate. You get y squared is negative x squared plus a constant. And then to resolve the constant, you use this information. So I plug in my 2 for y, plug in my 1 for x. So that's 4 is equal to minus 1. Minus 1. Some of you write plus 1 in those cases. Anyways, C is 5. So my final answer is, well, this C becomes 5. So I get x squared plus y squared is 5, is the equation that we're looking for. Okay. So let me just double check that before I move on. So, just have a look through. What did I do? Did I write that down right? Yes, I did. Did I write that down right? Yes, I did. Okay, I separated okay. Separate, integrate. Oh, I screwed up. I knew I was going to screw up. I made a mistake right here. Did I not? Well, it's best just to admit that you were wrong. So it should be divided by 2 right there, right? So this should be divided by 2, divided by 2. And then not 5 halves, but 9. Sorry, not 5, but 9 halves. 9 halves? 9 halves. 4.5. Yeah. 9 on 2. Okay. That looks better. .5. Yeah. Okay. Sorry about that. Okay, moving on. Another example. This one a more wordy one. Well, I used to work at Subway. I was a sandwich artist, and I would have to cool frozen soup. No, I would have to thaw. I would have to thaw frozen soup, and I would put it in a water bath. So I guess the opposite of what we're doing in this question. Anyways, my point is, working at Subway sucks. So stay in school, kids. Where was I? Okay, you have a water bath and you got your soup in there. And we got some information. about the soup going from 100 degrees Celsius to 60 degrees Celsius, and it takes 10 minutes to do so. Okay, we're going to use Newton's law of cooling. We will get to that in a moment. First things first, let's declare some variables. Y is equal to temperature of the bath. Oh, temperature of the soup, rather. T is time. So what do we do with that? We want to form a initial value problem. So we need a, well, derivative, dy dt, right? This is the rate of change of temperature. Rate of change of temperature. And we're told it's proportional to the temperature difference. So the soup temperature, which is Y, minus the bath temperature, which is 5. So this is the proportional symbol. Okay, what it means is that dy over dt do some constant times y minus 5. Okay, here's my differential equation. Now I need a initial condition. And where can I get that? Well, I need to use initially at 100 degrees Celsius. What does that tell me? Y equals 100 when t is 0. And then we have this bit. After 10 minutes, it's 60. It's a different color. Blue. 10 minutes later, it's at 60. So y is 60 when t is 10. So my IVP, which I'm going to write down here, is y of 0 is 100, y of 10 is 60. So there is my initial value problem. Here I have two initial values. Why might I need those? Well, I need those because I already have a constant right here that I want to resolve. And when I do an integral, I'm going to have this plus c, which would be a second constant. So I will, in fact, be using both of these data points. Okay, moving on, I want to separate, integrate, celebrate. Separate. So what does that mean? I have 1 over y minus 5 dy is k dt. And I integrate both sides. Okay, so remember, I wanted to take this equation and put the y's over here, and then put the t variables over here. So I did that, now I'm integrating, and I get ln absolute value, y minus 5 is equal to k t plus a constant. So this is the plus c I was talking about. Now what? Now I should say to myself, this c is quite divisible. I would like to find it right now. So I'll use this data point to find C. So take that. I'm going to use it right here. So I get ln. Running out of space. Ln of 195 is equal to, well, just C, right? So there's C. 195.